Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by the students, faculty, alumni, and friends of York University. You'll now find us wherever podcasts are distributed. All right, everyone. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by one of our regulars, Marisa Nozari. Great to have her back again. And of course, we are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday night or 9 p.m. local Toronto time or Eastern time. It's about 2 a.m. UT if that's more your speed. And we are on YouTube live for the live portion of this broadcast. The York U Observatory, of course, works with our online public viewing program run by our amazing observatory team. So if you are watching live on YouTube or you're listening to the podcast later, we can get all of that good astronomy content to you. To navigate to the live show or to find out what the live shows look like or just more information in general, you can always check out our website, yorku.ca/science/observatory, and follow the links to OPV or online public viewing, or just click on any of our YouTube links that are on our website and you'll get there. For any questions or comments about past shows or suggestions for future topics, you can always email us at observe@yorku.ca. And of course, you can connect with us on social media as well. We are on Instagram at York U Observatory and Facebook at LNI Carswell Ops. All of our programs are free, but if you'd like to make a donation, you can see that same website, yorku.ca/science/observatory, and we actually have quite a fundraiser going right now, so you can win prizes, enter the raffle, and make a wonderful donation to help support our programming and see all kinds of cool stretch goals. So check that out. We are, of course, monitoring the chat room for questions over on YouTube. The current weather is a little bit mixed, but we have some hopes of clearing. I'll just go ahead and pull over to my co-host, Parisa. How's the weather where you are?
Hi, Elena. I'm glad
Hey.
to be back here. Yeah, no, I'm in Montreal and it's very, very cloudy here as well. So I don't have any hope for any kind of observing here, but I hope it gets a little bit clearer for you in Toronto.
Yeah, we just need a real clear spot and not a fake one. Um, we had a few of what are I believe termed in astronomy sucker holes where it just looks like it's kind of clearing, but then it doesn't. And it's been very, very much touch and go. So we'll see how it goes this evening. Maybe we're able to open fingers and toes crossed because tomorrow looks terrible. um, but our crew are actually inside the 1 meter telescope right now, keeping an eye on the all sky camera and checking the weather. So if it does clear, we will get live imaging. And if not, of course, if you're over watching live, we have beautiful archival imaging, which is up on our online public viewing. Now, I will just go ahead and start this episode a little bit differently than what we usually do. I just want to give people a little bit of I suppose, an overview about the fundraiser. So I mentioned it in the intro, and this is a special event. We've never done this before. And we have a lot of amazing stretch goals. So I want to just make sure everybody's aware that not only are we doing a fundraiser, but we have prizes and special events happening. So the official fundraiser event is yorku.ca/science/observatory, that same link I gave you guys before, but /AICO fundraiser, or you just click on the fundraiser from the main site. You can actually enter to win 3 different raffles, which sounds kind of um, maybe excessive, but they're all really cool. So the fundraiser is for repairs, tours, and has a whole series of events. Our first goal is to reach $5,000, and if we reach 5,000 Canadian dollars, we'll be able to finish all of the April 2025 tours and offer 4 new free public tours for school groups or similar. So if you don't know already, we already have 2 free events every week, and this is one of them. Being able to offer 4 new free public tours for school groups is great, but we're also, just to sweeten the deal, going to actually publish our incredibly popular and copyright commons copyrighted astronomically accurate fortune teller, which you can print off and make at home. And we'll publish it on the website if we hit this goal. So free digital swag for everyone. And because we can, we're going to print out 400 new observatory bookmarks that will be given out for free at our weekly events. And this is all just at the $5,000 goal, mind you. We will be drawing raffle winners from each of the two main raffles. So we have a private tour raffle where you could win a private tour at the observatory with up to 5 of your friends in the domes, and one winner will be chosen for every goal we hit. We have a supported observation raffle, so you can separately win a supported observing evening. So the AICO crew will help you get your data. So we will actually help you plan your observing, get your data, and have an observing evening, one per tier. And it will run as long as the main contest keeps going. There's also going to be a swag raffle, but it's only one because we only have one of the fabulous books written by Jesse Rogerson and Professor John Moores, who are donating a book that has, I believe, about a $50 value, and we're going to put it with a whole bundle of observatory swag. So you can have the zippable tote bag, the calendar, the poster, the t-shirt, the coffee cup, and all together have just the most fashionable person in the universe, basically. So that is only going to happen once, and we're going to only do it one time for the whole contest. And it will either be if we hit 10,000, which is a second goal, or if we reach the end of the main fundraiser event, which is January 5th. So if we do reach the second goal, which is $10,000, we will also be putting down a downloadable worksheet, a free online observatory event. We'll be able to prepare part of the atrium facility on the Arboretum parking garage, including putting in some shelves, and we'll be putting up extra prize draws, astrophotography, and all kinds of cool stuff. So check out the website, check out the fundraiser. I hope everyone is somewhat excited about it. And as I say, like if you like to do tax deductions or you just like to find cool gifts for people, check it out. So that's the extended opener. And Parisa, well, I think this is a good chance for us to go and get into this actual episode because we have something really cool planned for tonight. We've actually gone ahead and made this entire episode very, very observational. So I'm really actually quite happy with how it's come together. And you have a wonderful object to start us off. So why don't you take us back in time, Parisa?
Thank you so much, Elena. And all the fundraising stuff sounds so amazing. So I hope we get there. But get to this episode. And actually, December is a very cool month in terms of the astronomical events and all the discoveries that it's been made so far during the history. So one of the very like cool ones is like at the very like late November, like almost like a week ago, back in 1965, the first observation of the Crab nebulous pulsar happened. And this is very cool because the Crab Nebula is also itself is among one of the oldest nebula that has been discovered in the history, and it's even like recorded back in 1054 AD, recorded by Chinese and Arab astronomers. So the Crab Nebula is very particular by itself, but back to its pulsar, I just wanted to tell you what pulsar is. That just to give you an analogy a little bit. So I start with that. You imagine that we're standing near a lighthouse, and the light from the lighthouse flashes on and off, and it rotates. So basically, we can see the beam when it's facing to us, right? So, well, a pulsar also works in a similar way, but instead of light, it's shooting out beams of energy like electromagnetic radiation, which includes things like radio waves and X-rays. So if we have like X-rays or radio telescopes, we can detect these objects. So a pulsar is actually a type of neutron star, which is the remains of the massive star that exploded in a supernovae. So when a star dies, it collapses into incredibly dense ball, and that's what a neutron star is. And now a pulsar is a neutron star that is spinning very, very fast. And so to put it into perspective, which that type of star packs the mass of about 1.4 times of the sun into a sphere only about 20 kilometers across. And that makes it one of the densest objects that we know in the universe. And because it is very, very compact and rotates quickly, it has a strong magnetic field, kind like a gigantic magnet. And now here where it gets very cool because pulsar's magnetic field sends out beam of energy from its poles, and these beams sweeps across the sky as the pulsar spins. So if Earth happens to be in the path of those beams, we can see them, or it's better to say to hear them, because these are very high frequency object detected by like the radio frequency. So it's like light beams, it's like a light from those like lighthouses beam that I just already described. But instead of just lighting up in the night sky, the pulsar's being pulsed regularly like a cosmic clock. And it kind of like sounds like beep, 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 beep. So you basically detect all those like high frequency stuff within the spectra. And as I know, there's a like a telescope that we have in the BC called Chime that they do a gigantic like a pulsar survey. And basically they just do the sky survey all the night to see serendipitously if one of those pulsar just points toward the Earth and they can detect it. And there's so many studies in the morphology of those spectra to see where they're originated or a little bit think of their kinematics or do a lot of research that I'm not particularly familiar. But I know there's a gigantic survey happening. But pulsars are very super regular, and that what makes them so special because they also flash with an incredible level of precision, and this timing can be extremely accurate, better than best atomic clock that we have here on Earth. So basically, imagine we could time something with that precision of the accuracy of the pulsars actually. And astronomers really care about pulsars very much because back in 90s, the first exoplanets actually were discovered around a pulsar. And these planets are orbiting a star that is already dead and turned into a pulsar. And also we had back in the 80s that we discovered the certain type of pulsars that are so accurate and they could actually be used to measure the tiniest change in the space itself, that what we know as a gravitational waves, because these pulsars help to confirm the existence of these waves, ripples in the fabric of space and time. And so that's very exciting because there are a lot of open questions about the stellar evolution. And studying the pulsars can be very important for us to have a better understanding of what's a neutron star and how the magnetic field also affects maybe its surrounding and also on. Yeah, so pulsars are very interesting, and I chose that topic because I think it's very, very recent due to our access to radio telescopes because our technology are improving um, like very, very much faster than before. So we have more opportunities with telescopes like Chime to observe these kind of objects.
Absolutely. And as you say, in 1965, radio technology was really just taking off. And you can just imagine, the early 1960s, they had, all kinds of crazy sci-fi things that were happening. We had, of course, the moon landings. Interest in space was kind of at an all-time high, I would say. But radio was really starting to take off. And it's important to remember for people who maybe haven't done a lot of astronomy is that radio light is a form of light that can be emitted. It's just got a very long wavelength, and so we don't see it with our eyes, but we can see it with radio telescopes. And these radio telescopes allow us to find things that are potentially very, very compact because, of course, the Crab Nebula, as you mentioned, this was seen, the explosion was seen by ancient Chinese and Arabic astronomers and potentially others. who recorded the presumably large explosion that happened for their guest, creating a guest star for the Crab Nebula. And so the existence of something had been known by humans for literally tens of thousands of years. Something had gone on. So how I forget exactly when the original one was, but what is this like 3,000 years ago or something? I forget what the exact date is, so we'll let the listeners go ahead and check the date on that. But it was quite a while that this gas has been expanding. Um, Maybe not as far as 2,000 years now that I think about it, but certainly at least 1,000. And if we have, all this evidence that something extreme has happened, but we can't see the extreme thing because the neutron star itself is going to be tiny. Neutron stars are so incredibly much smaller than any other star out there. Most of them are going to be smaller than Earth, so at least in radius. And of course, we can't see it. It's so, so, so tiny. It's very, very hard to get any real optical observation. So we need the radio. And this is just a great example of what looking in different wavelengths, I think, can do for you. And of course, with CHIME here in Canada, they're looking at lots of things related to pulsars. They've got high energy, compact regions out there in the universe doing incredible things. I know they do a lot of fast radio bursts, which are actually from objects outside of our own galaxy, which is a really, really long ways away. So just incredible high energy high energy, high intensity things that can't be seen in ordinary light because they are, potentially too small, like the Crab pulsar, or they emit their energy in wavelengths that human eyeballs can't see, or actually, in a lot of cases, are actually blocked by the atmosphere. But that's a different problem. So yeah, this is a really, 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 really cool one, and of course, always a little controversial because it was Jocelyn Bell Burnell who first discovered pulsar PSR, what was it, PSR B1919 plus 21. And she was around for this one as well, and that was 1967. And the whole optical pulsations study was just taking off with this. So the Crab Nebula actually became so popular after this original discovery. I believe they even went off and started using US Air Force radar systems to try to pin it down. And the Crab pulsar, you know, implications and the way they've been able to chart its change in its spin. This is sometimes called that spin down, and that actually provided the proof that you're talking about, literally showing that gravitational waves should exist. And now, of course, we have gravitational wave telescopes. So this is just such an exciting time for for radio astronomy, and I think also for astronomy in general. Um, but yeah, she it is really, really interesting stuff. But I will note that uh, so the controversy around some of it, especially with the Crab Nebula, is that Jocelyn Bell Burnell, she actually did not get the recognition from the 1974 Nobel Prize in Physics. She was left out of that one despite being uh, the discoverer. So um, she has gone on to win other prizes though. So it's yeah, just amazing time in history, amazing time in radio astronomy, and a really awesome remnant that you can still see expanding through space, and it's energized continuously by this pulsar. I forget how long they would say for a total spin down. Do you remember?
Well, not on top of my head, but I correct myself because I think I mentioned like they're high frequency, but they're very low frequency stuff. But also, as you mentioned, that the like fast radio burst that also chime does, they still do not know about like their origin. And that's very like, we have some stuff that we are detecting already with these radio X-ray um like telescopes, and we still do not know where they come from. But no, I don't know on top of my head that like how long they will like last.
Yeah, I know that
But
for some of them, it's a really, really incredibly long time. I don't remember exactly what the crab pulsar was, but it was like some order of the age of the universe or longer, from what I remember from some of the other objects. So, but yeah, the of course first kind of teasing proofs of gravitational waves, which we now know are real, and they're still just completely sci-fi. It's
exactly.
It's like, wow, it's just, it's amazing that we can now see some of this stuff. And of course, with radio telescope improvements, CHIME and others, who knows what other kinds of interesting discoveries we'll be able to make.
Yeah, exactly. Like one of the reasons that our understanding about oh because still there are a lot of open questions. There's so many things that we do not know about how stars actually form um because we didn't have like that much accessibility to looking at those objects. And through time, yeah, with the advancement of radio astronomy and telescopes, we can look beyond all those dust and detect all those high or low frequency, um, like waves or ripples that like happening like through the space. But yeah, we have a lot of questions to answer about the stellar evolution and how these very high like massive star formation happening, which like ended up being a neutron star, and the pulsar is like basically a remnant of them.
Yeah, yeah, exactly. And as you say, so many wonderful unanswered questions. Just what astronomers love is their mysteries to mysteries to solve. And with these kinds of pulsars as well, it kind of gives you more accuracy than you have any right to expect from from a natural phenomenon because of their very high accuracy timing. It actually, not for the crab pulsar, but for some other systems, it's actually, I believe there have been some interesting planet. I'd have to check out what was the planetary system where they used a pulsar. So they'll put that in the quiz section of today's episode. But yeah, what exactly was the progenitor star that led up to the current pulsar and nebula system? That's one mystery that, even just general astronomers interested in stellar evolution might be still wondering about. And of course, the Crab Nebula can be seen in, radio, infrared, visible light, ultraviolet, X-rays, gamma rays. So they really imaged it in just about everything now. But the pulsar itself is so small and so near the center that it really took the radio emission before we could actually pin it down. And there's some lovely maps online that I definitely encourage people to watch. There's one, I think not visual, but near infrared camera on Earth that got a kind of a picture. So near infrared is outside of the visible spectrum. So that's if you have your regular visible spectrum and you go into infrared, that's where you get heat vision, or if you've ever seen the movie Predator vision. And then near infrared is around there. And looking in that wavelength of light with special instruments, they do actually have an animation that they've taken of the crab pulsar that they had to slow down because, of course, it's incredibly fast. So you can kind of see it, but I think so far it's still got nearly the limit for the spin down. I think it was just beaten maybe by the Vela pulsar. So it's the very fun case. Yeah, we could probably talk about that one the whole episode, but we won't.
Yeah, and then one more thing is just like, back in 1990s, the first exoplanets been discovered around a pulsar, and that's also very interesting topics because on what condition the planet will survive after like, the end of like the evolution of the star time. That is also an interesting topic for like planetary astronomy to looking into that at like because that's also a very interesting by itself because all those very high mass stars like facing a kind of like explosion. So the survival of those planets will be very interesting also to talk about.
Yeah, yeah, I think so. I looked it up. It's the 1992 pulsar planets. And yeah, there's a whole slew of them now that you can look up. Um, and they're actually shockingly good at finding even small planets. So there's a planet that was found around one of them that was, I think, one of the first real Earth mass planets um, that was around a pulsar because, of course, that super accurate timing gives you the measurements to actually get an Earth-sized planet um, quickly. So it's kind of awesome. But yeah, what would those planets be like? Kind of, I mean, presuming that the pulsar pulse is pointed not at the planet, um, which it would be sort of, you know, glancing blow or something. But we already know that pulsars don't have or don't seem to have any dust around them anymore. So it would be a very, very strange place to visit and well, likely a little bit dangerous as well.
Yeah, and I hope that the JWST can help us with that because I know like they're looking a
Yes,
lot of like
absolutely.
exoplanets. So a lot of maybe cool discoveries will come out in the following few years.
Yeah, yeah. Well, and especially getting into being able to see smaller planets and rogue planets as well, which GWST is going to be hopefully excellent at. I just can't wait for that paper to come out. Anyways, lots of fun things to look forward to. So I suppose, speaking of things to look forward to, if we don't have a radio telescope on campus yet, although I hope we get one. Um, but we do have an optical telescope. And optical telescopes are great for lots of things. So I'm going to take you back to not very long ago, actually. So mine's a little more recent, but also a really, really fun observation. So back in 2017, around about of November 29th through December 3rd, and then all the way through December 21st, the world of stargazers was very, very entertained, especially in the Northern Hemisphere and beyond, because we got a flyby of a really, really cool object. There is an asteroid called Phaethon, or sorry, 3200 Phaethon, and this asteroid is responsible for the Geminid meteor shower. And that might sound really strange because I just said it was an asteroid. And so, what is this thing doing? How is it depositing debris? Was it a comet? Is it a comet? Is it some sort of weird residual? So back in 2017, it actually had its closest approach, and we got a flyby because it has what's called an elliptical orbit. It goes around the sun in a much more extreme fashion than Earth does, and it doesn't actually come all that close to Earth very often. So 2017, we had an amazing chance, best chance for a while, and there's all kinds of debate about this thing. Is it perhaps it could be an extinct comet, or it could be some sort of rubble pile asteroid that's cracked and shedding rocky bits whenever it gets close to the sun, and maybe that's what's causing the debris field that we get to fly through with the Earth. But it's only 5.1 kilometers wide, and it actually goes around the sun in almost an Earth-like way. It completes an orbit every 1.4 years, but instead of going basically in a circle like the Earth, it actually takes a very, very stretched oval path. So it takes 1.4 years, but it sort of goes out, 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 and then zips around close to Earth, or well, sometimes close to Earth, very, very close to the sun, and then back out again. So it's pretty fun. So November 29th through December 3rd of 2017, it actually got brighter and brighter in the sky, but still pretty dim. So it went from magnitude 14 to 13, which is brighter. But at that time, there was still a full moon, so you definitely needed like a really good telescope to see it, even though it was getting closer and brighter. So by the time we got to December 5th in 2017, it had gone up to magnitude 12.6, which is now in the range of a small telescope, 6-inch or 10-inch or something like that, depending on where in Toronto you are. And of course, it got brighter and brighter as it kept getting closer. December 12th to 15th, it got to magnitude 10, which is still too faint to see with your naked eye. But at that point, lots and lots of telescopes were able to see it. So anyone with telescopes or really good binoculars got a pretty good show. And it stayed relatively bright. So this is not bright like Venus is bright. This is bright like um, I suppose things through very big telescopes can sometimes be bright. So it was still too faint to see with the naked eye for sure. And then as it moved away, it sort of fades and drops back down to lower or higher magnitudes, which are fainter. So the bigger the number, the harder it is to see. By the time we got to December 21st in 2017, it had gone back to 15th magnitude, which is you would need a big telescope for that. And interesting thing is because people were actually able to see a little bit of a size to it as it flew by, they actually got to see a little crescent phase too. So pretty cool. Now this is actually classified as a potentially hazardous asteroid, 3200 Phaethon. It is Earth orbit adjacent, I suppose, but fortunately with the models and its orbit, we're able to tell that it's not going to be hazardous for at least the next 400 years, probably. It's a really fun, interesting object in lots of ways. It's actually astronomically maybe the complete opposite of our previous object. It has no energy. It's emitting, well, just bits of rock is all, and it's not going all that fast, and it's not spinning all that fast, and it's tiny and low mass. But it's this strange mystery. It's a little tiny asteroid thing that might have previously been a comet. But it also does a really weird thing in its orbit. It gets close to the sun, and not just close to the sun, it gets closer to the sun than any other named asteroid. It gets so close, it's only 0.14 AU, which is closer than Mercury. It's less than half the distance that Mercury is from the sun. This is so close to the sun that anything on this little tiny, we'll call it asteroid, is going to get extremely heated. So if it had been a comet, anything volatile would just have to be gone. Or would it? So this is part of the mystery. So lead melts on Mercury where the temperature reaches about 800 Fahrenheit or 427 Celsius. So a nice hot baking oven temperature. Phaethon would be even hotter. So it's less than half the distance. So Mercury goes around to, you know, 800 Fahrenheit, 427 Celsius. Phaethon goes to 1200, 1200 Fahrenheit, or 627 Celsius. So this is not just going to melt lead, but lead will flow like water, and any aluminum will turn to just sort of soft putty. So this means that every time it goes around in its orbit, 1.4 years or 524 days, it gets absolutely roasted by the sun. Um, Crazy. So this is actually, possibly an explanation for Phaethon's other claim to fame as the parent of the Geminid meteor shower. Maybe getting this baked by the sun has done something to it to make little bits fly off. So it was discovered for this close approach and they've known about it for a while, but they found it officially in 1983 with the Infrared Astronomical Telescope, IRAS. And Fred Whipple, who old astronomy history fans might remember from some of his excellent books, he noticed that the Phaethon's orbit actually matched Geminids, and that actually clinched it as the Geminid shower source. So most of our showers for meteor showers, and just as a reminder, meteor showers are these lovely little light shows you get when tiny particles of dust happen to sort of run into Earth's atmosphere. And what happens is they don't just run into us, we run into them. As the Earth travels around the sun, it's really zooming along in this great big round car that's absolutely hurtling through space, going around our star. And we whack right into these dust grains that are kind of just left there by comets and apparently Phaethon as well. And it hits the atmosphere like bugs on a windshield and they get absolutely squashed. But when tiny dust grains go into our atmosphere, they don't just get squashed, they get superheated and they light up, leaving beautiful dust streaks. And whatever direction that it appeared to originate from is kind of just the direction that our little atmosphere happened to be driving through that region of space at that time. And usually it's associated with a position in our orbit, which is where, of course, the debris field would be, and they'll appear to come from the direction of some constellation in our sky. And that's why we call it the Geminids, because the Gemini constellation is where they just happen to appear in our perspective to be coming from. They're not really, we're just sort of running into something while traveling that direction. So meteor showers are really, really fun. And this one is a particular fun one. The asteroid itself is a mystery, if it's really an asteroid at all. And of course, if it had started out as a comet, getting heated by that extreme distance, very, very short distance to the sun, would have really done a number on it. Now, how it survived, I can't imagine. If it had been just a comet, well, a comet is an icy, gassy, dusty ball, and as it gets closer to the sunlight starts to heat up the volatiles, and you get dust-rich ice vaporizing off of the comet nucleus, and that sort of ejects into a beautiful tail, and that gets left behind, and Earth can slam into that. So the asteroid must be releasing tiny little particles somehow. They once thought that maybe it might have ice beneath its surface, but we now know that it would have been too hot for ice to possibly survive anywheres in that entire little lump of stuff. But 3200 Phaethon, it's heated to an extremely high temperature. So currently, and this is also a bit of a guess, but we think that perhaps the temperature is high enough to cause breakdown of the rocky material where it cracks and crumbles into dust, and so we're getting kind of a dusty rock particle outgassing instead of ice. So it's kind of an interesting experiment. But if you've ever accidentally poured boiling water on cold glass, the glass will shatter. Likewise, if you try to put hot glass into cold water, it could shatter from thermal shock, unless you've done it just right in your glass blower. So thermal shock can cause things to break up, and solar heating can break Phaethon's crust rocks. And some of the particles have been measured as about a millimeter across for what would happen if you fractured dust at that temperature. And that's actually about the size of the Geminids for the most part. So of course, this was a really, really interesting time back in 2017 when we're finally getting a close-ish look. And it was a mystery because before 2017, back in 2009, at perihelion, astronomers had actually recorded a surprise doubling in the asteroid's brightness. So some sort of outburst from the surface. Oh, mystery. So yeah, meteor showers require constant replenishment, and Phaethon seems to be replenishing, but it would have to put out 10 times as many flares as are observed. So we don't still quite know how it's putting out the dust that we see. So it's obviously still a mystery. We're going to have to wait though to get more information, and hopefully we'll have better telescopes. But after the 2017 event, it won't get that bright or close again until December of 2093, which seems like a really long ways away. But hopefully telescopes will be really excellent. Uh, if you're around in 2093, let me know how it goes. Phaethon will pass 0.02 AU of Earth, and it will be magnitude 9, so even better. So it's a little bit of history and a little bit of future. But yeah, great adventures in Phaethon and meteor showers.
That's very cool. I do remember not the Gemini meteor shower, the Perseid meteor shower. That was actually at the time that I was coming to Canada. And I was so lucky because I could see some meteors above the cloud when I was on the plane. And that was just super, super crazy and cool. So if you're having any flight during that time, just I think if you're above the cloud, just looking outside, if you have a window seat, that would be so cool if you can catch them.
Oh yeah, absolutely. And of course, the Perseids are the perfect ones to mention because, of course, they are made from a comet. Much very very different different beast, and
Yeah,
we feel like we understand them.
exactly. But like talk about the those meteor shower and asteroid and all those cool stuff. I had another astronomical history event that like back in like next around like next week back in 2001 we got the that it was very important for the planetary science because on this day astronomers discovered an asteroid called 2001 YB5, and it was like a near Earth object, or we call them like NEOs, that it just brought a lot of attention to its relatively very close approach to Earth, because that was like such a huge one, measuring around 300 meters in diameter. And this asteroid zipped by at a distance of roughly 830,000 kilometers, of about twice the distance to the moon. And that discovery was a part of like a larger effort by an observatories worldwide to map NEOs. And it was like a mission that continues to evolve with the advancing technology, and programs like NASA's Planetary Defense Coordination Office now lead the charge right now. And they aiming to identify and, if necessary, mitigate threats from space rocks like 2001 YB5. And to my very late knowledge, I think we roughly know like all the asteroids that might come close to Earth within the next 100 years. Because we need to track these gigantic asteroids to probably not extinct to be like dinosaurs. And hopefully, I don't know what will happen. And if like asteroids like a size of 300 meter just cross by the Earth and probably have a chance to um, collide with us, then what technology do we have to defend? But fortunately, nothing dangerous within the following 100 years. I mean, to the last, I think, observations that NASA is doing. But yeah, that's
Yeah.
very interesting thing to think about, that we need to do something if we have
Yeah,
the
well,
technology to
there was
do
a whole
so.
series of movies about Earth impacting asteroids at some point. But yeah, I mean, we there of course there've been the recent DART, which was the asteroid redirection project, where they tried to do a deflection, and that seemed to work actually really well. But you're right, it's there's just there's so many things out there, and of course you have Asteroid Watch from NASA and JPL and the NEO studies and the Earth monitoring programs. But you still hear about things coming in that surprise them, and it's the incredible difficulty of measuring low albedo, non-reflective asteroids. Is definitely a problem that could probably use a little more attention because it's these things can be very, very, very hard to spot and extremely, extremely faint. And of course, it's like, it's like seeing a black cat on a black rug. You know, you you might not see it until you're right there. So the danger, of course, is that we've missed one, and we don't have our asteroid redirection program working yet. But like you say, I would say fingers and toes crossed. But I'm hoping the next 100 years are asteroid free as well.
Well, to their last reports, they said it is, and I hope because, as you
Yeah.
said, we don't figure it out until it's like right into our face. And I'm not thinking that an asteroid up a 300-meter will be fun to crash to us. So yeah.
Yeah, well, we've all seen the craters on the moon. But yeah, it is worth noting that at least, yeah, the DART was double asteroid redirection test, so that was a great success. And at least we have had some local successes in asteroid redirection with was it Didymos and Dimorphos, sorry. Hard to pronounce. But yes, we could use some more asteroid redirection successes just in case, I think. But yeah, excellent choice for the theme. I think we probably want to go ahead and move on to news soon so that we can share some of the amazing sky events coming up. But let me just go ahead and do a quick reminder here for everyone. You are all listening to York Universe, broadcasting live from Allan Carswell Observatory. We're located at York University in Toronto, Ontario, Canada, where unfortunately the clouds have just moved in, so we cannot open the 1 meter telescope tonight. But we have beautiful archival images happening live on online public viewing over on our YouTube channel if you are listening live. And of course, if you have any questions or want to see extra content, you can always visit our website, yourq.ca/science/observatory. Tonight, you're listening to Elena and Parisa, and we're discussing all kinds of amazing observations. And I'll just mention that you should also swing by that same website, yorku.ca/science/observatory, and check out the fundraiser because our observatory is doing a special fundraiser just this month until January 5th to try to hit some goals for repairs, funds, and of course, renovations. And of course, extra tours. So let's go ahead and move on a little bit through our show notes. I think we probably have time to do maybe one more quick This Week in Space and Astronomy history and then head on to news. Parisa, do you want to do the exoplanet?
Yeah, so basically, those on December 4th, 1995, astronomers Michael Mayer and Didier Queloz, if I'm not pronouncing it wrong, so they made a discovery, the first exoplanet orbiting a star like our sun. They named it 51 Pegasi b. And this planet is a gas giant about half the mass of the Jupiter located 50 light years away in the Pegasus constellation. And what amazed astronomers was how close its orbits its star, because it's completing a full orbit in just 4 days. And that was unlike anything that we have in our solar system, where a giant planet like the Jupiter are far from the sun. And that discovery was opened a new chapter in astronomy that suggests that the planets exist beyond our solar system and we can look into them. And as of December 2nd, 2024, we know that we have around 5,787 exoplanets across almost 4,000 planetary systems, with 969 systems hosting more than one planet. And so, we've been so we did that survey like a lot that we could discover that as of 1995, the first discovery that exoplanets till now that we know up to 5,000 exoplanets exist.
Oh yeah, that's um, the amount of exoplanets and the number of exoplanets has really skyrocketed. It's really a case of the more you're able to see them, the more you see. And it's the same problem in galactic archaeology, really. But yeah, the Kepler mission, of course, has done amazing things, and I hope we can do more with JWST and more satellites in the future because it really is the case. There are just so many planets out there, and we just can't see them because, of course, planets are almost always so incredibly small and dim compared to their host stars. But yeah, the 51 Pegasi B really was a real inspiration, I think, for sure, and one to keep looking at because it would be interesting to know, what the other planets in that system look like, and of course, by watching it over long time periods, maybe we'll find some more. And occasionally they do. Every once in a while, you see they release a confirmation of a second or a third or even a fourth or fifth planet in the system, because they're looking at wobbles in the star usually. Not always, but usually. But yeah, just such a cool system and such a wonderful planet. And of course, since you mentioned Jupiter mass, I'll just say on our way to the news item that this week in history was spectacularly good for observing. We actually had 11 moons of Jupiter discovered in December of 2001 by CFHT, the Canada France Hawaii Telescope. So amazing observations, amazing time and space, and all very, very good reasons to look up, even if you've only got a small telescope. So we have great stuff happening in the news. So our news this week is all about what's in the sky and some fun observing stuff. If you are in the Ontario area, please be aware we are doing this broadcast from Toronto. So if you're in the southern hemisphere, you'll want to go ahead and change your star maps to some other location. But for the northern hemisphere, we've just got great stuff out. Parisa, do you want to do yours first?
Yeah, so I'll just give you an update of like what's happening in the first week of December. So for all the amateur astronomers who are very excited to go and shoot some cool photography, that will be a great opportunity. So December 4 and 5, we have the Moon and Venus conjunction. And so if you look west right after sunset to catch a beautiful, beautiful crescent moon and Venus, the brightest planet in the sky, it's like obviously Venus, but and then shining an incredible magnitude of -4.2, and it will appear close to 15% illuminated moon. And that will be so they will be very, very close at their closest, just about 2.3 degree apart. And on early on December 5th, that this will occur below the horizon. So this is the best time to just enjoy shooting it if you like, just early evening twilight. And then move on to December 6th. There's a very other great things happening. That's Titan's shadow transit on Saturn. That is a very rare treat for telescopes user if you have small telescopes. And because the shadow of the Titan, Saturn's largest moon, will pass across the planet's disk. And this Titan is very interesting because it has a very thick atmosphere and lakes of liquid and methane. So during this event, that shadow will create a dramatic effect as it moves across Saturn's surface. So that's also very good chance to see planetary dynamics in real time. So you can also enjoy seeing that. And just a quick move to December 7th, we have Jupiter at the opposition, which means Jupiter reaches a position like means directly opposite side of the sun from our perspective. And that alignment makes Jupiter visible all night. So you can have it from sunset to sunrise, and it will shine the whole night. So if you have the small telescope, that is a perfect time to observe all the clouds, bands, and moons, and all the details of the Jupiter. So I think that was mine for the first week of December.
Yeah, absolutely. And those are all wonderful tips. And of course, if you do need any extra resources to help you if you're trying to plan your observing, I'll just give a little plug to our observatory website, yorku.ca/science/observatory observers. And we've got a whole bunch of target tools for Jupiter's moons, the red spot transit calculator, Saturn's moons as well, the Triton moon tracker. So we put a whole bunch of tool links and stuff down there. So if you are trying to do those calculations, feel free to run and use them. A little FYI, don't miss, I think, December 7th as well. The moon and Saturn are going to meet in the night sky. Half moon and Saturn are basically make great sky buddies, so good for star hopping. And of course, a little something to look forward to. Next week, December 13th, 14th, the Geminid meteor shower will hit its peak. So this is the same Geminid meteor shower that we talked about for so long with 3200 Phaethon, the asteroid. So if you want to go ahead and see the Geminid meteor shower that happens due to the asteroid, that you can totally see coming up on December 13th and 14th. So the asteroid itself is far too dim, so don't try to point at that one. But the actual meteor shower is supposed to be pretty good this year. Fingers and toes crossed, of course. It will be in the direction of the constellation Gemini. All right, everyone. I think that's all we have time for this evening. I would love to stay here and tell you everything that's up in the sky, but we do have to head off for the evening. So you have all been listening to York Universe, our amazing radio podcast, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. For all of our website and, of course, our amazing fundraiser, which is still ongoing, yorku.ca/science/observatory for chat, questions, content, and more. Tonight, listening to Parisa Nozari and Dr. Elena Hyde, and we've talked about all kinds of interesting stargazing and observing stuff tonight. You can always connect with us on Instagram at YorkU Observatory and Facebook at Allan I. Carswell Obs. Thank you for tuning into York Universe. Clear skies, everyone, and have a good night.